sharing the notebook. Let's see, in a minute, I'll be sharing the notebook that, let's see. Okay, let's see. Nope. Wrong screen. Sorry, I'm fumbling around to find the notebook that I want to share, but I'll be with you in a minute. Yeah, that's the one. Okay. Let's see, what are you actually seeing right now? Am I sharing something?
Yeah, two notebooks.
Two notebooks.
Plus
Does one of them look like Quora question pairs?
Yeah. Yeah.
Okay, that's what I want to be sharing. Okay, that is the one that Steve posted on the Stanford 224N Slack group. So you could, let's see, I think he posted it on that. Let me just look back. No, I think he posted it on Kaggle, on the Kaggle group. And so if you wanted to follow along on your own machine, you could get that one. So it's under Steve Roberts. And it's, let's see, it's the post from yesterday at 12:38. Quora question pairs using BERT. That's the notebook that he built. And he used, I think he started with something from Manis Nessan, because he had done an earlier submission to that Quora question pairs competition, and then Manis Nessan took his notebook and modified it and got a better score, and now he's taken Manis Nessan's notebook and adapted it even, modified it even further, and got a really good score. So I wanted to just sort of go through that notebook since it's, we're trying to learn BERT, and this is a great application of BERT. So here we are, Quora question pairs BERT from Steve JCat. Is that what you're seeing right now?
Yeah.
Okay, great. So here we are. So I hadn't been familiar with the Jovian ecosystem, but apparently it's a way that you can keep track of your notebooks and modifications that you make and so on. So, and that's what Steve's using. So first thing he does is he imports this Jovian ecosystem thing, and you do that. And then this is the part where you have to get things to work on your own Google Drive. So this is a sort of standard incantation that you have to make. And he defines some directories, a root directory and a base directory. Then he installs this Kaggle software that allows you to download and upload files back and forth between Kaggle. Then you have to do a key setup, both for Jovian, it has its own key setup, and you have to do a Kaggle key setup. So the only thing that you have to watch for here is that you're pointing to the correct directories where it can find your Kaggle API key. And that's usually in this directory, a .kaggle directory. So you just have to point it to the right directory. So some of these directory names you might have to change for your own machine. I did. To make it work. Okay, so the next thing you can do now that you're able to download stuff from Kaggle, you can actually download and unzip the data set, get the training file and the sample file and so on, and then you move the test file somewhere else so you don't get to look at it. So that's what he's doing here. Next, he's setting up BERT. I guess this is the model garden from BERT. If you're, I don't know if you're from, I haven't seen this before, but is this what that is, the model garden from TensorFlow?
Yeah, it's probably where all the relevant models are stored.
Yeah, I think they call it the model garden, which is a kind of cool name for it. And then here's all the imports and so on. Let's see, just BERT. This is where you download the particular BERT model that you want. Uncased I guess you have a choice when you can choose whichever model you want, and this is the one that he's chosen for this task. But I guess that means 768 for the hidden, and the number of heads is 12. I think you get to choose that. Okay, so he does that. He's listing. Let's see, and this points to the URL of the model that you want. Let's see. I'm not actually sure what. So he specifies a folder. Then he lists the files in that folder. And so it has the vocabulary. It has a model with its configuration. I'm not sure what all this is. HBS TF Hub TensorFlow. So this is where you get that model, I guess, from online. Okay, so then he sets up the tokenizer, full tokenizer, and the vocab.txt file is here. So, okay, so that's what he's doing here, and it's a 30,522 vocabulary size. To just tokenize a question to make sure that it's working. And it works. Then you encode all the questions. First you need these special tokens. The CLS, remember, that's the initial token that starts the pair, the sentence pair. And then the separation is the token that separates, that you insert at the end of each of the two sentences in the pair. So once he's done that, you can then train. And let's see, specify the training set. Then you replace nans with an empty character, and you do it in place. Then you look at a few examples of the training set and its pairs of questions. Okay, looking at the first question, this one. And then you can tokenize it just to make sure that it's working. Let's see. Truncate the number of tokens. Not sure where that truncation. Oh, it's to 10. Okay, so you're truncating to 10. And there it is. Okay, and then set the max tokens to 50, encode, he has a function to encode all the questions given a list. Let's see, okay. So each, I guess each sentence of the tokenizer gets a separation, an SEP token added after it, as we're supposed to do with this BERT model. So that's that. Then he runs question one. Then he runs this little function on each of the two questions in the pair. So that's all he's doing, is just adding this separator token at the end. And then you see. Yes.
One quick question. He created the list. So isn't the tokenizer, what does the code tokenizer is, if you look up here, list, yeah. So he's returning the list of the question which we are sending. So
yes.
So tokenizer is, what's the tokenizer is sending for? Is it, in a sense, because we are sending the whole sentence as a one go?
Yes, I think that's what this S is. S is a sentence that's input, right? And then it converts. First it makes a list of the tokens. Then it appends to the list the SEP token to the end, and then it returns convert tokens to IDs of tokens. So I'm not sure what convert tokens to IDs.
Maybe. So my question was for a list. So maybe
That's
because he's
numericalization step.
Hello, yes? Someone? Arto?
Yeah, I was saying that convert tokens to IDs is just a numericalization step.
Okay. So, but I thought that's what this does. Tokenizer.tokenize. I thought that's what that
No,
does.
it just splits tokens to, like, it splits sentence to tokens, and
Okay.
so we just do it separately.
Got it. Okay. So does that answer your question, Dinesh? So you give it a sentence, which is just the text. Then you split as Arto said, you split the text into its tokens. Then you add this separator token to the end of the sentence, and then you numericalize everything into into the numerical form of the tokens.
But the IDs, what's the difference between a tokenize and IDs? Like, is it tokenize is nothing but converting them into numerical form?
Convert tokens to IDs is okay. So here, the output of this thing, the output of this tokens.append SEP is still going to be text tokens. You know, it splits the sentence into the pieces. If it was just doing words, then each token would be a word. It's still in text form. And then, and what Arto is saying, this last part here converts those text tokens to actual numerical values.
Got it.
Yeah, but, Dinesh, what I don't recall, and maybe Gautam or somebody else, maybe Joseph, you recall, is the tokenized part. What it does is, remember that BERT, and this is the part I don't recall whether it uses word piece or sentence piece, or it assembles the tokens, it builds up its vocabulary, right, using pieces of words. And that's what the tokenizer.tokens of the words does. So it doesn't necessarily use words as is, it uses tokens.
Okay.
I think since the pre-training is already done, the actual building of vocabulary is done in the pre-training step. That we are not doing that here, I think.
But then the tokenize would still use that vocab to tokenize it though, right? The questions would get tokenized, then converted to IDs.
Yeah,
It
and
might
the
not be
tokenization
building-
could be sub-word tokenization, or it could be
Exactly, that's
word
my point.
tokenization. Yeah,
Yep,
we don't.
that's
I'm
my
not
point.
sure what. Yeah, I'm
So
not sure
that
what.
tokenize is the vocab which he lists with the BERT, I guess.
Yes.
You know? So it's using the same vocabulary.
Yes,
whatsoever.
it would have to use the vocab to Gautam's point, meaning you are not building up the vocab here, but you're using that vocab to break up the words in the current sentence into the tokens that are existing in the BERT model's vocab.
Yeah.
Let's have a look at some of those words. We could, because here's the vocabulary is given. Let's see. Oh, but we won't. Let's see. vocab files. I just wanted to see if I could look at some of those
You
tokens.
see here in hello TensorFlow, it splits TensorFlow into tensor and flow parts in this example here.
Yeah. It makes sense. Go up a bit.
Sorry.
It was the example up there which Arto was saying. That's a very good example, actually.
Which one is that?
This one. Yeah. It just front of you. The mouse. No. Yeah. Oh, down below. Just below cell number. Oh, yeah.
This one? Okay.
Yeah.
Okay. There we go. So it is words apparently.
Yeah, and interestingly here, like tensor got divided into two parts, or rather three: tensor, hash flow, and exclamation.
Yeah.
Yeah, this is where the word piece gets used, Srinivas.
Yep.
Not
That's what I was
sentence
saying.
piece. Yep.
Yeah.
So
it's
this
word-
hash must mean that it's a piece of a word or something like that. I'm not sure what that means.
Indicates that it's a subword. That is
A subword.
part
Okay.
of a subword.
Okay. Got it.
And interestingly, the capital words got converted into the small, like so everything is lowercase.
Yeah, because he used the uncased model, right? So
Yeah, that's right. That's right.
Good point.
That's right.
Hey,
Okay.
Joseph, sorry,
Yes.
so I'm happy to do the second half. Apologies, I forgot about your
Time
US
change.
time change.
That's what we figured. Yeah. So, okay, that's great. Good to have you with us. Yeah. So we're just going through right now. Steve's notebook for the Quora question answering that he posted in the Kaggle Slack group. He's basically showing how to use BERT, the sentence, the two sentence, well, I guess the sentence similarity part of BERT to help with the question answering, the Quora question answering problem. And he built a notebook that got a very good score. We're probably waiting for him too, because he wanted to go through this note. I asked him if he wanted to go through this notebook with us, and he said, yeah, but it's possible that he's thrown by the time change. So
Yeah, almost certainly. Yeah.
yeah, okay. Okay, well, I'm glad you're here. So anyway, shall we go on? We were just at the point where it tokenized everything. Oh, sorry. I forgot where I was. Yeah, we went down coding the questions. So what is it? We did that. We were here. Yeah. So so now we apply this function to the two parts of each question, the two sentences for each question, and there are 404,290 examples of each one. And then we look at one of the questions encoded in its numerical form, and it looks like this. Now the last step is to put this to prepend. That means to put at the beginning of the sentence a CLS token. And concatenate the ragged tensors to form a single input word IDs tensor. So he's basically going to concatenate these two sentences. And remember, each one now has an SEP token at the end. He's going to concatenate those two questions and then put a CLS token at the very beginning. So that's what this next step does. Convert CLS to a numerical, let's see. So he's building this array of CLS tokens that is the size of question 1.shape0. So that's the number of examples. That would be the 400 and whatever that number was. 404,000, yeah, 404,290. So that's what this question 1.shape0 is, 404,290. So he's building an array of CLS tokens that has that size. Then he's concatenating that array with these two along axis -1. That means the last axis, I think, right?
Yep.
So let's see. I'm not sure why you had to use axis -1.
I believe this is a column-wise concatenation. Is that?
Right. But why doesn't he just say axis 0 if that's true?
0 is okay. Yeah.
I don't know, but that's what. But I think you're right. This is a column-wise. Each one of these sets are columns. A column of 404,290 entries. We've built another one that has the same shape by the previous command. It's just a column of CLS tokens, and now we're just concatenating that with the first question with the second question to build that data set. And then there's a nice little visualization of what it looks like. This is the token number, so you can see how the sentences have different numbers of tokens in them, and there's 400,000 of them. And that's why he had to use this ragged tensor, this ragged constant data type, because each one of them it's not expected to have the same shape. Okay, so yeah.
What do you mean by same shape? I thought we are taking maximum 50 token, 50 or less.
Yeah, but it's a max though, Dinesh. So if your thing is below that, then it would not go to the max. It could be, it's just saying that maximum number of tokens is 50, but your sentence could encode to less than 50. So it doesn't mean that everything will have 50 tokens, right? Because your questions depends on the number. If your question 1 or question 2 is less than 50 tokens, then you will not have the 50 tokens filled up. So it's still ragged.
Yeah. So padding we're going to do afterwards, I guess.
Yep. So that's what he has done though, right? By normalizing the shape.
Okay.
Yeah, and they get padded. The rest of them get padded, right?
Right. Yeah.
And so here's what it looks like when 2 tokens are put end to end. They can have a maximum of 100, right? But most of them, as you can see, most of them have way less than 80 even. So yeah. Okay, and then someone had a question.
No, is this specific to TensorFlow, or is there an equivalent in Python? Or let me figure it out. No, I'm not.
No, you would have to do that for it. No, it's specific to BERT in that sense, right? Or specific to the part that you're using tokens, and the tokens are not. You would do this in basically any language model where you're even doing for any sequences, and you would have to standardize the sequence length if you're passing it to an RNN of any kind or LSTM, because that length is fixed. So you always pad in to equalize the lengths.
Right. Okay.
Okay. So
but
now
tensors are specific to TensorFlow, right? There is no equivalent in PyTorch, as far as I know. Ragged tensors.
The ragged tensors. Yeah, maybe in TensorFlow you'd have to explicitly pad everything and then convert it to a 50 length or something, and then you wouldn't have to use a ragged tensor. But perhaps ragged tensors are a way to compact the storage or to use less storage. I'm not sure. Anyway, the next step, you have to give it a mask and an input type. So the mask allows the model to cleanly differentiate between the content and the padding. The mask has the same shape as the input word IDs and contains a 1 anywhere the input word is not padding. So we've seen this before when we looked at the TensorFlow model. So this is what the input mask corresponding to this set of words looks like, and you can see that the shape is similar. It's just that instead of having variable values along the horizontal direction, the values are all 1 where there is an entry there, and they're 0 otherwise. So that's why the mask has just only 2 colors. Let's see. Input type has the same shape, but inside the non-padded region contains a 0 or 1, indicating which sentence the token is part of. So let's see. Input type.
Yeah, so that says, are you in question 1 or are you in question 2 within the non-padded part? Because the non-padded part is made up of both question 1 and question 2, which he has concatenated before. So you want to distinguish between where the question 1 token ends, or set of question 1 tokens and set of question 2 tokens.
What's throwing me is that it looks like the question 1 sentences are always shorter than the question 2 sentences, unless I'm misinterpreting something. Because this is 0, question 1, and the yellow is question 2. So it looks like question 1 seems to be always shorter than question 2, but I'm not sure.
Yeah, hard to tell from that picture though.
Yeah, and here it looks like there's an interruption. There's like a 1s and then 0s and then 1s. I'm not sure why it looks like that. And here's another one where it looks like there's a 0 stretch of 0s in between 2 stretches of 1s. That's just a little strange. Anyway, so the next step is to import the garbage collector, free up memory before proceeding. So he's deleting all these unneeded arrays. Remember, we combined question 1 and question 2 into one. We concatenated them, so we don't need them anymore. why don't we need the input mask? Let's see. PF1's input mask. I'm not sure why he's throwing away the input mask. Oh, yeah, he's deleting that.
He probably just computed that for illustration purposes, but further he is going to compute them on the fly. Like you take a batch and then calculate input mask and input.
Oh, okay, okay. Okay, I see. That makes sense. Okay, so the next step is to collect the above text parsing code into a single function and apply it to each split of the data set. So these are the things that we went through step by step above, where we tokenize each sentence and then add the extra tokens that BERT uses, and then concatenate everything and make the input mask and so on. And so here's the function that does all that. Then we do the splitting of the training set into a validation and training part. Then this is an interesting step. He swaps the questions to double the size of the training data, right? So instead of having, so for each example, you switch the order of the questions, and then you have another example. And now you have double the number of examples. So let's see. In the initial split, he had 20% for the validation set and 80% for the training for the new training set. 80% of 400,000 is probably this, but and here's where he appends. He builds the duplicate set and then he appends it. So now. So this is 80% of the original training set, which remember was 400,000 something, and then here is double that because he's using the duplicate set. So he's putting both together. So now he's got a new training set here. Just to looking at the pairs, looking at some of the pairs to just check that the data set looks good, and another set to look at. Oh, I guess now he's looking at he's looking to verify that the two sets of questions that were switched are there. So this is the first question. This is the first question switched, and it's indeed switched. And I guess he's kept an is duplicate tag. Oh, so some of the questions are already duplicates, and there's an is duplicate tag. I don't think he's talked about that before.
No, that's the target we're aiming to train for, Joseph. That is duplicate is 1 or 0 indicates whether the question is a duplicate or not. That's the goal. Is
the goal of the core
test set to predict? Yeah, is
okay.
Unseen questions to predict are they duplicate or not. That's the goal of the exercise eventually.
Okay, so is duplicate means it doesn't mean that they're exactly the same, but that they're essential, that they're equivalent sentences.
Yep.
Okay, and how so you're familiar with this. How do they compute that? Are they just looking for a cosine similarity?
No. In fact, that's our goal, is to figure out. So they provide a test set, which we, in the Kaggle competition, this is training data, right? So they give you the answer.
This is given. Okay.
Right. And then the test for this Kaggle is to predict to an unseen test set what, based on your training, and use the model to predict whether is it duplicate 1 or is it duplicate 0. Meaning, are the two questions duplicates of each other or not?
Right. Okay.
That's
so yeah, you can see. Right. So you can see here, these are two questions, and they are given a tag of 1, and you can see why they're given a tag of 1, because they're very similar questions. Okay. Okay. So now he's checked that the data set looks like he expects it to. He appends the labels onto, let's see, train labels equals train labels dot append train labels. I'm not sure what's going on here. Yeah, the training labels are the same for both of these duplicate sets. We've just switched the order of the questions. So he's basically just concatenating the training labels with itself to make a new copy that has, you know, 2 copies of the, you know, the training labels for the concatenated set, where he puts together a set of the questions with the switched questions. Remember that the questions and the switched questions both have the same labels. So to build the labels for that set, all you have to do is make 2 copies and put them together. Does that make sense? That's what's going on here. So now we've got the labels for the training set. And so now is the step for training, or this is the encoding step, and it takes 5 minutes, so we're not going to go through it all. He does the encoding for the training and the validation sets. Let me see. He didn't need to do the duplication step for the validation set, and that's because the validation is just going to be used to evaluate the model. Okay. Key value and training. Key. Okay. Each subset of the data has been converted to a dictionary of features and a set of labels. Each feature in the input dictionary has the same shape, and the number of labels should match. So this is that dictionary that's created by the tokenizer. And I guess this is the vocabulary length. Oh, this is the length of the sentences, and we see that it's 103 because each sentence is a length 50, but each sentence also has that extra SEP token at the end. So 2 sentences together would have 51 plus 51 tokens, or 102. But then remember, there's that CLS token at the very beginning, so that's why this thing has length of 103. So just checking the shapes are right. Shapes of the input words, the input mask, and the input type IDs and the train labels should all have the same shape. Okay, for key value in train.items. Train.items, I guess, is all of these things that are needed for the model. And we're printing the key and its shape. So the key for that part of the dictionary, yeah, okay, so the dictionary is divided into these 4 keys, and their names are here. Let me see something. Train insert code cell. I just wanted. So this, if I understand it right, this should be a dictionary. Oh, I can't do this because I haven't started them. The notebook is not live. Sorry. Can't do that right now. Anyway, but so that's what I think is going on here. This is a dictionary, and it has these 4 items in it. So these are the keys: input word IDs, input mask, input type IDs, train labels. And so it's just printing the names of the keys and their shapes. And we verified that the shapes are correct. So, and looking at the labels, they look like they should look, with 0s and 1s. So remember, its duplicate is the core labels, as Srinivas told us. Okay, so next we download a pre-trained model. BERT config file, BERT config. Thought we had already downloaded the BERT pre-trained model. Can anybody explain what this step is doing? Spent that join GS folder BERT. Okay. I guess these are we can understand what these things are. These are the hyperparameters in BERT. But, so this config dict is the hyperparameters that are set. So you can see dropout is 10%. We're using GELU for the hidden activation function. Hidden dropout probability is the same. Hidden size 768. Initializer range, I'm not sure what that is. Intermediate size, I'm not sure what that is. Max position embeddings is 512. That's characteristic of the BERT model, I guess. Number of heads is 12. Number of hidden layers is 12. Those are standard for the BERT. Type vocabulary size is 2. I'm not sure what this parameter is. And then the vocabulary size is 30,522. We've seen that before. Configuration, the config defines the BERT model, which is a Keras model, to predict the outputs of num classes from inputs with maximum sequence length, max seq length. The function returns both the encoder and the classifier. So, right. But I'm a little confused about what this is doing here. Oh, it's just the, okay, they're using, I guess the config file is in JSON format. So that's, so they're importing this, I guess they're pointing to the name of the configuration file. I'm looking, I think that when they loaded the BERT model, they got this with it, maybe. So now it's building the configuration dictionary by loading that file. And then they get out the configuration dictionary so they can print it. But I think above, when we loaded the BERT model, we must have gotten this file with it. Let me just check really quickly. Back up. Somewhere up here yes, there it is, bertconfig.json. So this is one of the files we imported when we imported the BERT model. So now it's just accessing that, that file and showing us what's in it. Sorry, I went too far. Still went too far. Oh, we did this. We did this. We did the encoding. Here we are. Okay, so here we're getting the model ready. We're just looking at our configuration file. And you know, I guess at this point you can change things in this file, but we're not. We're just going to leave it as is. The config. Okay, so we see that the config defines the core BERT model, and the function. Yes.
Question, but can you really change it though? Because it's now pre-trained for that config, right? So I don't think you would be. I don't know which of those parameters you can and cannot change, because I would imagine the default would be you can't change because you're pre-trained to that model, right?
That sounds right. That sounds right. Yeah, I think you're right. Although the dropout,
sorry, is the type vocab size, because I thought the type vocab size, and that's why maybe I'm reading that wrong, but I thought the type vocab size would be that I interpreted it as, you know, him having 2 sentences, but that doesn't seem right because that is something he did later, and I am skeptical how that showed up in the original BERT model that he downloaded. So I don't understand what that is.
Yeah, I don't either. That's the one thing that I didn't understand. I mean, I can, you know, we recognize these numbers from the standard BERT models. I don't know what this is either, the 3072, if anybody has
BERT
any.
by default takes in 2 sentences,
Intermediate
right?
size, I think, is a size of feed forward. You know, in a transformer layer, you have feed forward part, and it like expands and then squeezes back this dimension of inner vector. So it's like 4 times 668.
768.
And that's the dimension of feed forward.
Makes sense.
4 times 678. Is that 4 times 678? Is that
768?
768. Yeah. Yeah. I don't know what the initializer range is either.
Yeah. Gautam's point is very valid too. He has a point. Go ahead, Gautam. Explain what I think you're right. The type vocab size. Yeah.
And
I'm
type
not sure
vocab
if it
size
relates with
might
type
be
vocab
it's
size.
connected with like when you have when you pretrain BERT, you might have more types. Like here we have 1 and 0 for first and second question, and if but BERT is pretrained on this dual task when we both try to predict if one sentence is prolongation of the previous one, and also we are using masked language modeling, and maybe it's possible that we have more types.
Yeah, I think Gautam was pointing to that, right, Gautam?
Yep. By default, when you pre-train BERT, they always give pairs of sentences, and like he was pointing out, both tasks are done. For masked language modeling, it's just prediction of the masked word by using the other words, and the other task is the next sentence prediction. So yeah, by default it takes 2 inputs all the time, and when you want to use BERT just for a single sentence, you can still do that. I mean, it supports both, but by default it's designed to take 2 sentences as input.
So the other possible value for type vocab size is 1 then, if you don't use the sentence.
Yeah, I'm not sure
part.
if that relates with type vocab size, but yeah.
Okay.
It takes 2 sentences.
So it does. So Srinivas's point is taken that it doesn't look like you have a lot of flexibility with to choose other parameters. The only ones that I would say you do would be maybe the dropout probabilities. I mean, you should be able to adjust those in your model. Those shouldn't be fixed. But anyway, so that's a question. I don't have the answer to that right now. Okay, so the function returns both the classifier and the encoder. That's the way the BERT thing works. You can get the encoder back all by itself. Let's see, 3 inputs and 1 output. So you have the input type IDs, and you have the input mask. You get the encoder, dropout 1, and the classification. So I guess you're just doing the dropout at the end, just before the classification layer. BERT classifier. So let's see. So I guess this is just the off-the-shelf BERT. But I think we do have to. I guess the BERT classifier does have its own classification layer at the end. I forget what the problem is. The 2 sentences that go in are supposed to be. You're supposed to decide whether one follows from the other or one is the next sentence from the other. I think that's what the off-the-shelf classifier does, right? The off-the-shelf BERT decides whether the 2 sentences are ordered in such a way that the second sentence follows from the first, is the next sentence after the first, right?
Yep.
Yes.
Yeah. So its classification is already set up to answer that question. And so this is the way the model looks. The 3 inputs, the encoder, the dropout layer, the classification head, and yeah. So they count up the number of parameters, 110 million parameters that are trainable and no non-trainable parameters. Okay, so now we've got this model. We just run it on a batch of 10 examples and look at the output. And I guess these are BERT classifier. Training equals true. It comes out in, the output is in pairs of numbers, and I'm not sure. I guess these may be the logits that come out of the classifier. I'm not sure exactly. We're looking at the output. that's what I'm thinking is if these are the logits, and then you can put a sigmoid on top of it to get probabilities. But let's just see what happens at the end. That's my working hypothesis here, is that these are the logits that would go into a sigmoid activation function to get the actual probabilities out. But let's see if that's right. Okay, transformer encoder is center. Okay, so now we're looking at that encoder. Okay, so we just looked at the classifier and looked at what its output looks like. Now we're looking at the encoder part and looking at its structure, which is a lot more complicated. Let's see. Here are the inputs. Embeddings, dropout. Transformer, there's 12 transformer layers, I guess. I'm not sure what the lambda is. And then finally, there's a pooling layer. So that's what that looks like. Okay, then here's a point that when the encoder is built, it's randomly initialized, but we want to restore the encoder's weights from the checkpoint. When we imported this, we had weights with it. So let me just go back up and have a look at that. Sorry for scrolling so fast. Here is something. Part of what we imported was this BERT model.checkpoint.index and BERT model.checkpoint.data. I'm imagining that these are the files that contain the pre-trained weights, and that we need, and that the next step down below is where we tell them that no, we don't want the randomly initialized encoder, we want the pre-trained weights. So that's what it's doing here. Next, we set up an optimizer for the problem. I guess BERT uses the Atom optimizer, the Atom W, which is the corrected Atom optimizer. And so this is just the off-the-shelf BERT, and it employs a learning rate schedule that firstly warms up from 0 and then decays to 0. So it goes up and then back down. We've seen this in the Leslie Smith paper. So here are some of the hyperparameters they're setting up. 4 epochs, batch size of 32, batch size for evaluation of 32, train data size, steps per epoch. You just divide the each step is a batch. That's what they mean by steps. So you just divide the training data size by the number of batches, and that tells you the number of batches per epoch. Number of training steps is steps per epoch times epoch. So that's the total number of batches that are going to be processed when you go through 4 epochs. And then warm-up steps, epochs plus epochs times train data size times 10% divided by batch size. So it's taking 10% for warm-up, taking 10% of the first epoch for a warm-up set. I'm not sure what the warm-up is. Firstly warms up from 0 and then decays to 0. Okay, so I guess the warm-up step is a rapid, it's 10% of a batch, so it goes up rapidly and then the rest of the batch is coming down to 0. So that's what the shape looks like. So then the next part is to create the optimizer with that particular learning rate schedule that you just defined, and that's what's there. And then the next step is
sorry.
Yeah.
Just could you repeat again? What's the warm-up step, please?
Well, it looks like it's 10%. Okay, so remember he's talking about a learning rate schedule that looks like this. It goes from 0 and ramps up to 1 and then ramps back down to 0. So now here he's defining what that actual ramp looks like. The warm-up part is the part that goes from 0 to 1. And it looks like that's done with 10% of an epoch. So for each epoch, 10% of it is a warm up, and the rest, the other 90% is the decay part where it decays back to 1. Sorry, that decays from 1 to 0.
Yeah, if you look at steps per epoch, that's trained data size by batch size. So essentially epochs in the number of epochs times 10%. So as Joseph explained, it's just that 10% of the steps are used to increase the learning rate, and then the rest of the 90 you drop the learning rate.
Yeah. So the learning rate is going to look like a triangle kind of thing where it has a rapid ramp up and a more gradual decline. Does that make sense, Dinesh?
Yeah, makes sense. Thanks.
Okay. Okay. So the next step is training. We first have to define the metric. We're defining sparse categorical accuracy. I guess this is making use of the sparseness of our data set. And for the loss, we're using cross entropy. And from logits equals true. So that verifies what I said before, that the inputs are logits. They're just, the logits, remember, are the inputs that go right into the sigmoid model. It goes into the logits are the numbers that are the inputs into the logistic function, which converts them to probabilities. Does everybody remember that part? Any questions on that? So it says from logits equals true. Yeah.
I have a question. I think sparse categorical would be used when you have many classes and your row would only belong to one of those classes. I think, but yeah, any of you could correct me if I'm wrong. I think in this case you would just use the normal accuracy or whatever.
So you don't think it's necessary to use sparse categorical accuracy in this case?
And I think, yeah, I mean, he could have just had one node in the output layer instead of 2. I'm not sure why he did 2.
Hi there, Joseph. Sorry,
hi,
I just
Steve.
joined the meeting.
Yeah, I'm sure it's because of the time change, right?
Yeah, I hadn't realized you guys had gone to winter time.
Yeah, that's what we figured. That's what we figured. That's the one problem with these calendars and so on. When you schedule an event on a calendar, it doesn't know where the origination of the event was, and that's the information you need to know what the actual UTC is.
Yeah, our clocks went back last weekend.
So and ours are going back tonight.
Right. Yeah. So I just assumed you were the same as me.
Yeah.
So no I'm running an hour late here. In terms of the sparse categorical accuracy, as I said to you, like a lot of this notebook is just copied directly from like the TensorFlow example notebook.
Yes.
And yeah, so like in their example, again, they only have like a single output, but in their model they use 2 outputs, like one for 0 and one for 1 effectively.
Yeah.
And so they use the sparse categorical accuracy. Yeah, because like originally I tried this, and instead of having 2 outputs from the network, I was trying to just have 1. But it didn't work very well. Basically, their whole sort of BERT model seems to be set up to have multiple categories, and when you select the label parameter, like if you select 1, I looked at the code and like it basically sort of drops back to a funny regression model if you do that. Mm-hmm. I was expecting it to have sort of like 1 hot encoding on the output, but
normally the output of a binary classifier is going to give you 2 probabilities, the probability of 0 and the probability of 1, and I think that's what's going on.
I thought it would have the softmax layer on the thing, but it doesn't. It has it has logits, and so taking sparse categorical accuracy, that's just what they had basically, and like as Gautam said, basically it just copies what's happening on the loss function there.
So they didn't really need it. They didn't really need the sparse categorical accuracy. They could have used the ordinary categorical accuracy, right? That's what Gautam was saying.
Was Gautam not saying that like if you're basically out of your outputs, you just want one of them to be your answer and you don't care about the others? Is that what it means, where you've got like 1 out of many? as your
I'm
answer?
not actually sure. We should probably look up this function and understand why they used it or why they didn't need to use it or whatever.
I think yeah, even I'm not that familiar with this. So when your label is a huge one-hot encoding vector, suppose you have like 10 classes and you have a one-hot encoding vector as your label, in that case I think you would use sparse.
Yeah.
Yeah, I could be wrong.
Okay. Let's just do a quick lookup, just because you know, so we'll settle this question once and for all. Okay, so what does it say? It says logits. Okay, you provide logits. We've already, okay, 2 local variables. Doesn't give much in the way of description here. Calculates how often predictions match integer labels. We do have integer labels, so I guess it's what you use when the labels are integers, because that's sparse, right? If you had a continuous label, then you know, then you couldn't use this. I guess the reason why they're using it is because the labels themselves are just integers. In this case, 0 and 1.
It's explained in a sparse categorical loss section.
Ah, okay. Wrong. Oh, because it's not, it's loss.
Entropy or something.
Is this losses or loss? I'm just guessing. If not, I'll, nope. Okay, I'm going to go back and get the right.
I think it is losses, sorry.
Losses, okay, losses.
Yeah.
There we, nope, didn't like that either. Oh. Okay, no problem. We'll just go back and we'll go back and get it.
I send the link to the chat.
Ah, thank you. Let's see. I'm on the wrong page. Chat. Hold on for a sec. Yeah, it's hard. There we go. I've lost the chat window. That's okay. I'm gonna. There it is. Got it. Okay. Are you seeing that now? Are you seeing what I'm seeing? The losses. We're at the right link that.
Yeah.
That's one said. Okay, so we're looking at that. Categorical loss computes a cross entropy loss between the labels and the predictions. But why does it have to be sparse? Does it explain? Here. Use this cross entropy loss function when there are 2 or more label classes. We expect the labels to be provided as integers, and that's what we're doing here. If you want to provide the labels using one hot representation, please use categorical cross entropy. Isn't the 2 labels the same as one hot? Oh, no, I don't understand. We have 2 or more label classes. Oh, I see. And each one of them has, so the class is given by one integer, either 0 or 1. But if you provide them instead with one hot, that would mean you'd have 0, 0, and or 0, 1, and 1, 0, right? That's what the one hot would be. It would be, you know, 0, 1 for the first class and 1, 0 for the second class. Then you would use the ordinary loss. I'm still not quite sure about why they're doing it, but any case, makes sense to me. So let's go back to the notebook.
So I think we don't need sparse here, right? Since we just have a single output. Okay, you have 2 outputs here. Okay, but if you are using a single output, then it's just 0 or 1. You can just use the normal cross entropy loss, I think.
But it says that you use the normal cross entropy loss when you have one hot encoded output, and that's not what we're doing here.
Yeah, but if it's a single output, It's essentially the same as 1 hot, right? It's just 0 or 1. If
I
it's a
see.
1.
I see what you're saying. Yeah. Okay. So Gautam's point is that we could have just used ordinary. Oops, I'm on the wrong notebook.
Is it not that if you've got one hot encoding, if you've like taken the softmax, if you've got a softmax layer on the output of your classifier, then you've got the probabilities, whereas here we're just the logits, and so like here we've just got, although the labels are like integers, the values that we're outputting are floating point.
Yes.
That's why you have the from logits equal to true. It does the softmax part by itself. You don't have to do that.
Yeah, as I say, this was just copied directly from the TensorFlow example notebook, so I used the same loss function and the same metrics that they had, and like their system was identical, like in that they've only got sort of one output, but they split it into two labels.
So even in PyTorch, they have the same thing. You don't have to actually do softmax manually. When you calculate the loss using cross entropy, it does the softmax part and calculates the loss for you.
It knows that the inputs are logits because that's what you specified here.
Yeah.
So okay. So Gautam's point is we didn't need to use the special sparse categorical cross entropy function. We could have just used the categorical cross entropy function, and the same with the accuracy. So here's this part, and this is the longest part. This takes a couple hours, I think. You see, it takes an hour and something, an hour and several, maybe an hour and 10 minutes or something like that for each epoch. So that's this part, the long part. So I ran this last night, but I'm not running it today. When you're done, you can save it, and then you can use these. I guess there's a function built to show the training graph, and that's what it looks like. There are 4 epochs. How come there's only 3 data points? 1, 2, 3. I'm not sure why it's only giving 3 data points.
That's my function. Sorry, if you look at the actual function to draw the graph again, I might. Oh yeah, see start equals 1. Sorry, I've cut the first one off.
Okay. Okay, that's fine.
Yeah. And, sorry, I just pulled this out of another notebook, which, like, if you've got like your first epoch in some systems tends to have like a massive loss, and then it drops down. So I chopped the first one off just somewhere else. So that's why it's missing here.
Okay, that makes sense. Okay, and then but the thing to look at is the training and validation accuracy. The training accuracy goes up very quickly to 99%. The validation accuracy, the model is not. Well, okay, the loss is decreasing, but the accuracy is staying pretty much constant around 91%. It's increasing just a bit, but at least that's a really good result. So next, you run that model on a custom example to see if it works. So you basically kludge up a couple of questions and see what it gives as the answer. And so it's saying that the answer is 1 for class 0 and 0 for class 1, meaning that I believe that means they're not the same question. No, but they are the same question.
Well, I thought it was like it was giving 1 for the first. So you've got 2 questions going in. Question 1, there's 2, and question 2, there's 2. So
yes,
the first question 1 is, will a BERT model give me a better score? And that there is being compared against, do BERT models give better Kaggle scores? And so I think it's like saying 1, yes, they do. Those questions are the same. Then the next question is, when was Ludwig van Beethoven born, or where was he born?
Oh, okay. There we go.
We've talked about this in our Kaggle group.
Yeah.
And like with the universal sentence encoder, it would come back and say that those sentences are the same because like their vectors, their embeddings are identical practically, but like they are completely different questions. So here I think it's like now saying that these questions aren't the same.
Okay, so it gave the right answer then. But I guess what I misinterpreted, and this is what Steve just set me straight on. So you're kludging up a little data set here. The question 1, there are 2 examples for question 1 and 2 corresponding examples for question 2. So the first example is The first part of question 1 is the first, and question 1 could have 400,000 entries in it, right? But we're just looking at the first 2, let's say. So this is the first question, and these are the 2 corresponding sentences, and they are the same questions, and it correctly says that. And the second example is when was Ludwig van Beethoven born, and the corresponding question is where. And as Steve said, they're not the same question, and so the model correctly decided that.
Steve,
yeah.
Is that because of the BERT model requiring 2 sentences for each of its thingy that you're providing the question 1 as 2 questions, or is it
that's what I wanted. Yeah, sorry, I didn't make that clear. Question 1 is the data set of all the number 1 questions, right? So this could have a length, it has a length of 2 in this case, but it could have a length of 400,000. It's basically the set of all question 1 entries. And question 2 is the set of all question 2 entries. In this case, we have a small data set that only has 2 examples in it, right? But in the general case, we're looking at, question 1 will have a length of 400,000 or 600,000, right? And question 2 will also have a length of 600,000. Does that make sense, Srinivas?
It's the same as like a bit further down, we'll put through the whole proper test set.
Yeah.
So it's just the same as sticking through the big massive data frame, which has got its question 1 column and its question 2 column, where there's pairs of question 1 and question 2s.
Yeah. So question 1 is a column of questions, and in this case, the column only has 2 entries in it. And question 2 is a column of corresponding number 2 questions that are to be compared, right? And in this case, the column has only 2 questions in it. So this and this belong together. We're asking if they're the same question, and this part and this part belong together. We're asking if they're the same question. And so since the input has 2 elements in it, the output will also have 2 elements in it. And the output is the end of the classification layer. So now we're no longer dealing with probabilities. We're actually making the classifications. That's what we did when we built this. Model, right? There was some place where it said from logits equals true, right? So the classifier is just going to give us one output, which is either a 1 or a 0 for each of our inputs. Okay, so yeah. So next step is the same as before. We've used the garbage collector to free up memory. I guess now we don't need, let's see. Oh, we're just going to look at the test set now, so we can delete all the training stuff. And we can delete the classifier as well. So read the test set, replace nans with an empty string. I'm not sure why that's needed, but they do that. So
because there are a couple of empty strings which need to be replaced, or else it'll cause problems in the processing. So
nan, a couple of none entries. Okay. Looking at the test data set, here are the pairs. So this is what Steve was talking about. There's columns, question 1 and question 2. In the kludged up example we gave, there were only 2 rows, and each, as we said before, right? This is row 1, row 2, row 1, row 2. So here they are. Here is what it looks like in the test set. Should I have a hair transplant at age 24? Blah, blah, blah. Okay. So we do the same steps as before to get the data ready. We tokenize it. We load the model. I guess somebody was talking about this TQDM that sets up a progress bar for us. So I guess that's what they're doing here. I guess, Steve, you wrote this, right? So you could talk us through this.
Yeah, this is actually my bit of code. the test data is like much bigger than the training data, and so I was having a lot of problems where it kept running out of memory. It kept running out of GPU memory. So like that's why there's like a lot of garbage collections going on. As you can see, like previously I got rid of the training set and like actually deleted the model, and then I bring it back in again in the loading. And yeah, so here basically I had to split the test data into effectively like a load of batches, whatever. So it was like 1,000 batches. So it does whatever the test data size is divided by 1,000 on each batch. And that was the only way I could get it to actually run the classifier without running out of memory. So yeah, it's just working its way through the test set, building up that all results array with the results that it gets from each set of question pairs. Yeah, I tried with the TensorFlow, sort of with their notebook, they show you like other ways of sort of putting it into a TensorFlow data set, but I wasn't really familiar with those, and they seem to be the examples they had. They have like a lot of TensorFlow sort of pre-built data sets, and sort of like a lot of the examples they had just showed how to make data sets from their own sort of test data sets as opposed to making them out of sort of pandas data frames. And so yeah, this was the only way I could get it to work without running out of memory.
Makes sense to me, yeah. And then
it's maybe not the most efficient way to do it. I think you could do it like, like with generators and yield and stuff, but I couldn't get that to work.
Yeah, that's fine. So, and then you notice the training equals false because we're just doing inference now. So, and then okay, well, I guess Steve, you could just talk us through the rest of this because we're almost there.
Yeah, so it's basically, as I say, like it just runs through a batch at a time. Then, so the stacking thing just, so it's got like 1,000 NumPy arrays, and the stack just sticks those back together again. Then, like as we said before, the actual output of the network is just logits. So I needed to convert those into probabilities. So that's why the softmax is there. So it takes the logits and makes softmaxes instead. So that gives like the probability of it either being a duplicate or not a duplicate. But we only want the column that says it's a duplicate or not. So that's column number 1.
Yeah.
So yeah, so like it takes the softmax and then it takes column number 1 to create the test df as duplicate column. Yeah, so like at that point, that's the work done basically. So it's made all its predictions, and we've added those predictions into the test data frame.
You're just building the output file that you need to submit, right?
Yeah. So when you looked at like the training data frame, it had question 1, question 2, and then the third column was as duplicate for training. Yep. Whereas when you looked at the test one, it only had question 1, question 2. And so, yeah, we've now formed the is duplicate column, which is the column required for the submission. And then everything below is like the automatic submission to Kaggle. And below that then is like the automatic submission into Jovian to keep track of the notebook.
So question, softmax maps any number of outputs into probabilities, right? Given that they're logits. But in this case, we only have 2, so we could have used I don't know if there's a function corresponding to the logistic function. Is there another way to do this, just using the logistic function, or is that just the way you take care of it in TensorFlow? You just use the softmax for any case.
I don't know. I just used softmax because I knew like it would like take the outputs or whatever and sort of make them into probabilities where they add up to 1. So there could well be obviously like softmax is from a sort of logarithmic thing, isn't it? So obviously you could do it mathematically.
I think it's equivalent. Yeah, when n equals 2, softmax is the same as a logistic function. But okay, okay. So we built the file, and then you could talk us through the rest, the last bit where you submit, because this is kind of the interesting part where you get your data file ready.
Yeah, so like we've put the is duplicate column onto our test data frame, but we don't want all the test data frame to do the submission. We only need to have like the IDs of each question pair and the column saying if they're a duplicate or not. So yeah, so it just takes those two columns, and yeah, so creates a cut down version of the test DF file. And then the next bit is, yeah, like this is using Kaggle's API where you can like automatically submit into their competitions. So like the first line there takes our submission file and sends it off to Kaggle. It takes a while then to process it. So like the next line, the view results line, it will view the results, but the chances are it'll not have the results yet. It'll come back in a results file saying submitted, but you're waiting. So that's what the whole next cell in the notebook's about. It basically keeps on asking for the file every 30 seconds until eventually it gets like a results file back that says here's the results. So yeah, so it'll try 5 times every 30 seconds until it finds the results.
This is your file, right? Or is
yeah,
this
that's
something
right.
you built? Cool.
Yeah.
And then this part, so this is the part where you're making use of the Jovian ecosystem, right?
Yeah. So this part here, the results file that's come back from Kaggle should now contain the results, and like the two results it'll have, it'll be the score on the public test set and the score on the private test set. So as you can see here, this parses that text file and reads those values out of it and puts them into the public and private metrics dictionary thing there, which is like a Jovian structure. So it's logged it into our Jovian system. And then when all of that is complete, we do the final line at the bottom there, which is commit to Jovian. And like it takes all the parameters that you've sort of shoved into your Jovian object and commits them with the notebook title that started at the top. And it should take the notebook as well. And so like when you go to like look at it on Jovian, you should see the notebook and you should be able to like then compare every submission you've done like in a table, which shows you like all of the hyperparameters that you used in your notebook and anything else that you added in. So it'll show you the hyperparameters and the score that you got, and then you can like link on it and see the notebook, and you can like compare notebooks to see the differences that you've made.
Okay,
unfortunately,
so
unfortunately, there's like a bit of Jovian sort of struggles a bit with Google Colab, and to create like a Google Colab notebook that works successfully with Jovian, you need to actually create the notebook from Jovian to start with. And in this case, I didn't, whereas like the one prior to this I had. So like actually, if you go onto my Jovian page, what you'll see is the new scores, okay, but the actual notebook will be the previous notebook.
Okay, so I can get to your Jovian page by how? Let's see, I think I know. This is
the link. Yeah. So can you go? Yeah. So like that is this notebook. But if you actually go to the top of that, sorry a sec.
Right here.
Yeah. If you click on Tinkerty Tonk there,
Tinkerty
on the left
Tonk?
bit. Yeah.
Oh, okay. So right. Oh, that's your. Okay.
Yeah. So these are all my notebooks. So that one there is Quora Question Pairs BERT 1, which is the proper notebook. But if you click on the one to the right there, the one that just says Quora.
Yeah.
So these are all my submissions. So if you look at it on the right-hand corner where it says version 13, you were just on it there. Over to on the right hand side.
Yeah. Okay. Version.
Just below you.
Oh yeah. There.
One down. Yeah. Click on that.
Okay.
Yeah. So these are all the versions. Oh, sorry. Click on it again, and at the menu at the bottom, click on Compare Versions.
Okay.
Yeah. So this is how it's like meant to work, and like it shows you like every submission you've made. So like the first ones here at the top, like the very first notebook at the top there, it was a submission I made to this competition. It was just using Gautam's like universal sentence encoder with a classifier on that, and those are the scores I got. And so you can see they're about like 0.39 or whatever is the best I do. Then the ones at the bottom here, the empty, the ones that don't have any hyperparameters, these are now the BERT model ones. So you can see the best one there is like the 0.32.
Yeah.
And the last one there, it's the current notebook. But as I said, if you were to click on one of those, it'll not pull up the right notebook just because of a mistake I made in the creation of it.
Okay. Yeah, so I noticed when I ran this, I got similar results to these the first time, but then the second time I got results that were more like 0.5, 0.6. So I'm not sure what went wrong there. But you said that maybe what happened was it took the first model that I made and tried to improve on it. It took that as the starting point and tried to improve on it. And you were saying that sometimes when it does that, it gets worse.
Yeah, so if you look at like version 10 there, which is the best scores, like the 0.32, in that case there, yeah, like that notebook, it was only trained for 3 epochs.
Yeah.
Whereas like the one directly below it, I thought, okay, I'll train for longer. So like it was actually trained for 10 epochs, and as you can see, the scores get massively worse.
Yeah.
So if you were to take your pre-trained model and train it for some more, I think it's maybe because of the fact that the training set size is small that like it starts to really overfit and goes wrong. And then the one at the bottom, that there's actually using Gautham's idea of you can swap the questions over. So the training data has question 1 and question 2, and it says if it's a duplicate or not.
Yeah.
Whereas like the notebook at the minute has the idea where you can swap question 1 and question 2 and double the size of your training data.
Yep.
So that's the scores from that. As you can see, they actually got slightly worse, which was surprising, but it's maybe again because I trained it for too long and whatever. So I'm sure there's like a lot of ways to make things better.
That's really cool. So that's really nice that you did that, and I mean, as you can see, we learned a lot just going through that. At least those of us who haven't paid a lot of attention to the BERT, those of us who hadn't seen a lot from BERT before. So I really appreciate that, Steve. And I have to apologize to John because I told him that he was going to get 50 minutes, and now there's only like 20. I think that what we can do, John, is you could start what you wanted to do, and then you can continue next week.
Or perhaps I'll just start next week. That's fine.
Oh, okay. That's fine then. We can just end here then, if that's fine with everybody, unless there are other questions.
Yeah, no, I do have a question actually for hang on a sec. I have a question for you, Steve. So how are you creating these? How are you using Jovian with Colab? Which notebook can we use as to help us start things out?
Jovian and Colab, basically, they didn't used to work together at all. Jovian works fine. If your notebook was in Kaggle, it would work fine. The submission would be okay, but like they seem to have some problem with Colab where they struggle to actually sort of access the notebook from Google Drive or wherever it is stored. And so they've now got a thing in Jovian where if you create an account in Jovian and you go to your profile, you can click on a button which says create new notebook, and you can choose that new notebook to be a Colab notebook. And when it does that, it sets up all the sort of the wiring required to get it to commit successfully.
It's all done in this file that Steve shared with us, Jonathan. So John, so you can see, can you see what I'm sharing now? This is the post that Steve made in the Kaggle Slack.
Yep.
Can you see this?
Well, that there's actually though my notebook. But yeah, like if you want to actually sort of make a Jovian compatible Colab notebook, you need to start from scratch.
Steve, would you mind just showing us really quickly? Would you mind sharing your screen and showing us really quickly?
Yeah, I should be able to. Yeah. There is like it is a sort of bodgy mechanism that you need to run to get it to work. Let's see.
And while we're waiting for Steve to do that, just a quick one. What's the plan for next week, Joseph?
Well, you have the first half of it, and then the second half, we can figure out what to do. I mean, we could either do some more on BERT and just have that session all for BERT, and then move on to the next lecture on the following week. It might be nice to spend some more time with BERT, so let's count on that. We'll have you take the first half, and then I or someone else can take the second half and do something further in BERT.
Hi, John. Yeah, sorry, I'm not exactly sure how you do it again. I'll have to look it up. There is, like, in the Jovian help, like a pointer about how to do it. It actually tells you how you can take an existing notebook and sort of wire it up successfully.
And you've done that, right? You've done that, right?
Yeah. In the first one, yeah. So like over and back in Google Drive, it creates its own Jovian folder. And yeah, once you have this, once it's in the Jovian folder, then I think it wires it up. So like in my original notebook, it all worked fine. But as I said, I think it's like to do here.
Yeah, if you look in Steve's notebook that he shared, it actually has how he did it.
Yeah, and
you perhaps can upload your workbook. Let's say if you have the Quora, this one, if you upload it to a Jovian.
Yeah, you can see like this line here that I've now commented out. It's got like the Colab file ID, and when you create the notebook from Jovian itself, it'll automatically set this up for you. And I think this needs to be set right so that when you do the commit, it links the commit with the actual notebook that you're working on. And so I took this ID from my previous notebook, and so like every time I committed, it was committing an old notebook rather than this up-to-date one. But I'll look again on the Jovian help and find the article that explains exactly how to do it, and I'll post that on the Slack.
Great. Okay. Thanks a lot.
Sounds good. Any other questions before we adjourn? Well, thanks everyone. Yeah.
I have a quick question on the accuracy. Actually, well, loss and accuracy. I don't know if I missed it, but why was validation accuracy not going down?
Yeah, good question. I don't understand that either. Let me go back to the notebook. Let me see.
Actually, Yuri, it's something I wanted to discuss in the Kaggle thing as well. In fact, if you look, regardless, and I have to check with Gautam on his approach of the LSTM, but at least when I use the universal sentence encoding, or Steve did, or Gautam did, and then I also use the SBERT, your suggestion, and in every instance, I find this validation loss flattens while training loss continues. Training accuracy continues to improve. It doesn't even flatten, while validation accuracy flattens very quickly and stays flat. So that gap is something that's at least of the order of 3 points or so. Like, for example, whether it's USE or SBERT, I've found that, there's like 91 would be a validation accuracy and 94 and still not flattening. If you provide more data, it will continue to go up for training accuracy. So it seems like, that begs to provide some kind of other augmentation strategies to help narrow that gap.
Maybe we need more dropout, raise the dropout fraction.
I tried that. It didn't seem to substantially change the numbers. It helps sometimes a little bit, but not as much as reducing it significantly.
Okay.
I've seen as well with the with the metrics, with the accuracy metrics function there, it's got like a threshold of it of 0.5. So if the value's above 0.5, it says yes, I'm true, and less than that, it says 0, I'm not. And so yeah, like in the accuracy seems to improve normally in the validation set, even though like the loss is getting worse. So it seems to sort of get better at predicting what it knows already, but it seems to sort of predict more wrong as well.
Yeah, the generalization it struggles with.
Yeah.
That's weird that the oh, okay, I see. The training loss is going down, but the validation loss is getting worse. That's just weird.
If you look at your scores just above where you are at the minute, or if you look at the actual model training scores, yeah, there. So you can see the validation loss is getting a lot worse, whereas the accuracy on the validation set is getting slightly better.
Oh, yeah, that's weird. This is a cross entropy loss, so wait, validation loss. Oh, okay. So 0.22 is a really good loss, is a good cross entropy loss, but 0.4 is not so good. That's weird.
No, the validation loss starts off pretty well. It's like sort of generalizing pretty well, but yeah, by the end it's not
You're
too
doing
good.
worse, yeah. Yeah, I mean, like you're better just to use one epoch.
Yeah, exactly. Yeah. Perhaps I should have tried 0. It would have been even better.
Yeah.
Do you know if order of questions matter, or are they in random order when they're coming in?
Into training?
Yeah, well, yeah, in the data in Quora. So the reason I'm asking for that is I'm thinking maybe splitting, instead of randomly splitting, they should have like I don't know if they can be split per topic, sort of. I was wondering if there is a, but then that wouldn't help with validation loss, because so I'm afraid so if you randomly split splitting into training and test, there might be a lot of like near duplicate questions. But then in that case, so you just learn about like those questions. But then in that case, validation loss should be almost the same as training loss. So that's not the problem.
I had a question for you, Steve. We were looking at the hyperparameters for the model that came from that came in with the JSON file, and we were wondering how is there any room for where can you set the hyperparameters? Where can you set the hyperparameters here? Import JSON. This is what you get. This is what's already preset as the parameters. Where can you change those parameters if you, or can you change those parameters? Hyperparameters, I mean.
I don't actually know, sorry.
Okay.
Yeah, like those are just like the TensorFlow ones, so I'm not sure are they hard coded for the model that we're using here. I don't know. Can you actually sort of go back and change them?
Isn't that just the bird config JSON file that you're?
Yes. Yes.
Yeah, it is. Yeah.
So that just comes out. So that's just a record of what was done in the in creating that BERT model.
You can see on the next line there where it actually creates the classifier model. Yeah, there, that the top line has just disappeared off the screen. Yeah, so they stick it in there when they create the model. So like you could obviously maybe just play about with the JSON file and tweak those parameters. For example, like to give yourself more attention heads or whatever.
Or more dropout. More dropout.
Yeah.
And do you know what this initializer range parameter is?
I don't know. Sorry.
So that's another thing that
Yeah.
one could maybe play with. And then, do you know what this? We were wondering what this type vocab size parameter is.
I was wondering that myself. Sorry. Again, I'm not sure. I was wondering, was it tied to the fact that, yeah, originally I thought it was like to do with the number of labels equals 2, but I don't think it is.
Yeah. Well, I mean, I
presume
think
that,
Gautam
yeah,
was
like
saying,
back
yeah. Sorry.
This is all taken from like the TensorFlow hub.
Yeah.
If you go to the TensorFlow hub, they explain all the models that's available and all these hyperparameters. So
yeah, I think you.
but it was a bit of a black box, I thought, though. Like that was like the one thing about it. It was like sort of you just pull in the TensorFlow model and use it. And yeah, it seemed a bit hard or whatever to actually sort of modify it or customize it.
Yeah. So this is what you pointed to as the source of, as part of the source of your notebook, is this original TensorFlow fine-tuning BERT thing that.
Well, it's copied. Pretty much all the BERT stuff's copied directly from that, but instead of using that garden thing, yeah. So I just replaced it with our Kaggle data for the core question pairs one.
Yeah.
So yeah. So if you look at like that, it's identical, and like there again, they've only got one output, and yeah, so where you are now, actually, there, like again, that's just above there where they do the training. Yeah, so like that's where they use the, yeah, you can see there at the top line the sparse categorical cross entropy. So you can see they're using it.
Yep,
so
and they were using they were applying it to the glue. Sorry, to the what's that? That test set that Kaggle, sorry, that Stanford made. I forget what it's called. The Squad. They were applying it to the Squad data set, I believe, Squad 2.0. Yeah. Well, that's interesting. It's really a great piece of work that you did just to adapt that to the Quora question problem. I think it really helps us to understand how BERT gets used in practice. Yeah. All right. Well, let me stop then, and